Kia ora, this video's got a couple of examples of partial fractions problems. You'll want to watch partial fractions 1 before you watch partial fractions 2. So here we go. So the first question that I want to look at is to write this expression as the sum of partial fractions. Right, so the first thing that we're going to check before I get you to pause and have a go at it is look at the numerator, that's order 1, and look at the denominator, and that's order 2. So what that means is it's one of our easy types that we looked at in the first video, and it's going to be in this form. Hopefully. So we're going to have something here and something here. So I want you to go from there, pause the video and try and get right through to the end. I'm going to go over this one slowly on the next couple of slides and then do a second example and then a couple for you to try. Here's what we should have. Well, we've got negative x minus 20 over 3x squared minus 48. So hopefully you spotted the difference of two squares in the denominator. So we have this. Now it doesn't matter where we pop that constant term. I'm going to write it like this. Put our A here and our B here. Taking this to the next step, what have we got now? Well, we're going to expand the cross multiply on the right hand side, and we get this. I've messed up my identity sign everywhere again. It's a very bad habit. There we are. A times x minus 4 plus 3b times x plus 4. Now, what are we going to do next? Well, there's two ways to go here. You can do matching up the coefficients, and if you're going to do that method, then what you need to do is to expand out the right hand side and then collect up the like terms. So I'm going to start doing that because some of you may have gone that way, but it's not a very efficient method to use here, and you'll see why in a second. So if I start doing this, that's my first line of working. Right, it's going to get there, but it's just going to take me a wee while. So what I'd have to do next is collect up the ax and the 3bx and then match that up with the negative 1. Right, and the same thing here. Collect up the constant term, match it with the negative 20. But the faster way here again is to pick values of x that are going to get me to my a and b very, very quickly. So the first thing I'm going to do is choose x equals 4, and let's see what happens. Well, when x is 4, the left hand side gives me negative 4 minus 20 equals a times 0 plus 3b times 4 plus 4. So negative 24 is equal to 3 times 8, 24b. It gets me straight to b equals negative 1. Okay, then the next value that we're going to choose is going to be the one to make x plus 4 equals 0. I'll do that on the next slide. So we've got negative x minus 20 is equal to a so subbing in x equals negative 4, we get negative 4 minus 20 is equal to a times negative 4 minus 4 plus 3b times 0. Get rid of the bad yellow pen. So 4 minus 20, negative 16 is equal to negative 8a, a is equal to 2. So we're done, and we need to just write out our answer nicely. Negative x minus 20 over 3x squared minus 48 is equal to 2 over 3 times x plus 4 minus 1 over x minus 4. So that's the first example. Now the next one is a bit muckier, but I wanted to include it, but working's a little bit longer. Alright, so this one has got a quadratic in the numerator. So here's one that I made up. Express 6x squared plus 31x minus 2, and I've factorised the cubic here for you because it's going to be a little while until we can do that easily. So we want to express that as that, and I'm going to cheat here and just put SOPF, right, sum of partial fractions. So here's what we want to get to. We're going to want 6x squared plus 31x minus 2 over 2x plus 3, x plus 4 times x minus 2 is equal to a times 2x plus 3 plus b over x plus 4 plus c over x minus 2. Now let's have a look at why we can be confident that that's going to work. So looking at the order here, the order is 3, and looking at the order here, the order is 2. So it fits the pattern I said earlier, where the order of the numerator is below the order of the denominator. Just think about what's going to happen when we start putting back together what we've split up over here. We're going to have a, and a is going to be multiplied by those two factors. A is a constant times two linear factors is going to give me a quadratic. So that's what I want. So it should be going to work. So that's going to give me something x squared. Same thing here. When I've got b here, we're going to be multiplying in those two factors. It's another quadratic. And here c, going to get multiplied by those two there. Okay, so we can be pretty confident that the usual way is going to work out fine. And it would be the same if I had just a linear factor here, like x minus 4, or if I had a constant. Okay, where I'm going to have to be careful is where the order of the numerator and denominator is the same. And there's a few things I can do there. Right, as usual, I'm getting sidetracked. So we've got the denominator gives me the 6x squared plus 31x minus 2 is equal to a times x plus 4 times x minus 2 plus b times 2x plus 3 times x minus 2 plus c times the other two factors, like that. Now, I'm not going to expand them out. If you want to for practice, you can go ahead and do that, and then you'd use matching up the three coefficients, so you'd get three simultaneous equations with three unknowns, the unknowns being a, b and c. But I'm going to again use substitution, at least to start with. So I'm going to use substitution and say what value of x will give me a 0. Well, x is negative 4 is 1, and x is 2 is another. And then I'm going to have a think about this 2x plus 3. I can do that with a third factor, but there might be an even faster way. We'll see that when we get to it. So substituting in, I'll do the x equals 2 first. Substituting, okay, some strange thing just happened to the slide. Let's see if we can get it working. So here we go. We've got x equals 2. We substitute on this side, and then we substitute in on the right hand side. So we get 6 times 4 plus 31 2's gives me 62, take away 2, equals, well, here this gives me a times 0 plus here b times 0 plus c, and now I have to substitute in. So 2 2's plus 3 gives me 7, and 2 plus 4 gives me 6. So over here, this simplifies to 24 and 62. 86 minus 2, 84 equals 42c. So c is equal to 2. So that was very nice and easy. Okay, so now we're going to find the next factor. I'm going to do that on a new slide. Alright, so the next factor that we've got, I'm just going to put the equation back in. So I know this is slow and tedious for some of you. I'm assuming if that's you, that you are skipping ahead, but not too far. Right, so we've got this, and we've got A, and then we've got B times those two, and then we've got plus C times those two. Right, so that's the x plus 4, x minus 2, 2x plus 3, x minus 2, and lastly 2x plus 3 times x plus 4. So the next thing we're going to do is sort out what happens when x equals negative 4. So we sub in here. Let's see what we get. Well, we get on this side 96, take away 124, take away 2, and then it equals a times 0 plus b times, what's b? B times, right, 2x plus 3, so negative 8 plus 3 gives me negative 5, right, that's subbing in there, and then negative 4 minus 2 gives me negative 6, plus c times 0 again. So over here, what do we get left with here? Well, 96 minus 120 minus 126 gives me negative 30 is equal to 30b. So that gives me b is equal to negative 1. And from the previous page, what have we got already? I've lost track. We have got c is equal to 2. So we could go on and we could do our substitution on this one here. But it's actually easier now to say, well, all I've got to do is pick one of these and I'll do a match-up on it because I've got two of the variables in the simultaneous equation solved. So we've got the 6 from the 6x squared, and we can just pull out the x squared coefficient in here. Right, so this gives me ax squared from here plus 2b x squared from in here. Right, so I'm just looking at the x squared term. Right, and lastly I've got plus 2cx squared. So we can just write that 6 is equal to a plus 2b plus 2c. So 6, see if I can squeeze it in, 6 is equal to a minus 2 plus 4, that's just from subbing in those two, which tells me that a is equal to 4. Right, that's right. Okay, and so now our final answer is this. 6x squared plus 31x minus 2 divided by those three factors, which were x plus 4, I've put them in the wrong order now, haven't I? Never mind, and 2x plus 3, but I have to keep them in the right order for my a, b and c. So that equals 4 over 2x plus 3 minus 1 over x plus 4 plus 2 over x minus 2. Okay, on the next slide there are two that I want you to try. So coming up now, they're quite similar to the ones we've just done, probably a little bit easier. Right, so write as the sum of partial fractions. Oh, giving away the answer. Bad. Right, here's the first one. X minus 21 over x squared minus 9. That's the first one for you. And the second one is this. X squared minus 6x minus 5 over x plus 4 times x minus 1 times x minus 3. So there you go. Thanks for watching.